Okay, so back where we started. 95% of our data lies 2 standard deviations below the mean, or lies between 2 standard deviations below the mean and 2 standard deviations above the mean. So that means if we were to work out how much isn't inside these 2 standard deviations, do the same calculation again, 100, take away 95 equals 5. So we know that 5% of our data lies outside these 2 standard deviations. We know they're split evenly, so we divide 5 by 2. So we have 2.5% of the data is below 2 standard deviations below the mean. And 2.5% of the data is 2 standard deviations above, is above 2 standard deviations above the mean. All right, that's our 95% rule. Also in here, we know there's 95, and 95 divided by 2 is 47.5. So we know that between 2 standard deviations below the mean and the mean, this is 47.5%. And between the mean and 2 standard deviations above the mean is also 47.5%. So that's our 95% rule. And our last rule is the 99.7% rule. So I'm just going to get rid of this stuff again. And again, it's really similar, but as you can imagine, this time we are using 3 standard deviations. Not 2, not 1, 3. And I know you're probably thinking, what happens if something doesn't lie 1, 2, or exactly 3 standard deviations in the mean? That's not what we're worried about at the moment. Let's just get this in our head. We will deal with that later. So, let's write out those calculations so we don't look too geeky. Alright, so the 99.7% rule. So again, our mean in the middle. This time we are going 3 standard deviations below and 3 standard deviations above. Alright, now in between here we have 99.7% of the data. Okay, how much is on the outside? 100, take away 99.7 equals 0.3. We know that it's even on both sides. Divide by 2 equals 1.5. So in here, 0.15. So in here we have 0.15% of the data is below 3 standard deviations, and 0.15% of the data is above 3 standard deviations. We also know that if we divide this in 2, we have 49.85. So we know that 49.85% of the data lies between 3 standard deviations below the mean and the mean. And we know that 49.85% of the data lies between the mean and 3 standard deviations above the mean. Okay, so to start with, this is our 3 rules. Between 1 standard deviation below, 1 standard deviation above, we have 68%. In between, 2 standard deviations below the mean, 2 standard deviations above the mean. In between them, we have 95%. 3 standard deviations below the mean and 3 standard deviations above the mean. Between that, we have 99.7% of all our data. So now that we know this, what are we going to do with it? So let's have a bit of a look. When we first do this question, I'm going to do it with lots of diagrams so that you understand how this all relates and connects. But then I will move on to not using a diagram and show you how to do it without using it, because it's much quicker like that. But I want you girls to have a good understanding of what we're doing and why we're doing it and how we're doing it. So This does take a long time to explain, but once you actually get to doing these questions, it will actually become, you really understand it. You'll be like, oh, okay, I get it. And it is a really useful rule. Okay, so back up at the computer now. Okay, the chest measurements of an 18-year-old male footballers are normally distributed with a mean of 95 centimetres. So I'm just writing that down. So X bar equals 95 centimetres and a standard deviation of 8 centimetres. Okay, that's all the data we need. So once we have that data, we can put it on our graph. So our mean, which we know is always in the middle, is at 95 centimetres. Now our standard deviation isn't at 8, but what we can do is work out, by using that, what is at those standard deviations. So we have our 95 centimetres as our mean. So to work out one standard deviation below the mean, what we're going to do is we're going to go, so our formula for this is X bar plus or minus 1 standard deviation. So we can go 95, let's start with our plus 1 times 8, because 8 is our standard deviation, equals 103. So if we're using our plus, we know we're going to be above the mean. So at 1 standard deviation above the mean, we are at 103 centimetres. Now let's do our takeaway one. So we've got 95, take away 1 times 8 equals 87. So we know 1 standard deviation below the mean is at 87 centimetres. Alright, the reason we've got the 1 is because we were doing the 1 standard deviation. Now let's do it for the 2. So all I'm doing is just putting everything on our graph. So once we've got it on our graph, then we can just look at it and work things out. So let's do our 2 standard deviations. So we go X bar plus or minus 2 standard deviations. Let's start with our plus. 95 plus 2 times 8 equals 111. So at 2 standard deviations above the mean, we have 111. Now let's do our takeaway. 95 take 2 times 8 equals 95 take 2 times 8 equals 79. So 2 standard deviations below the mean is at 79 centimetres. Now what you may also notice is that we're just going 95, take away 8, take away 8, take away 8. So for this one we can just go, to get to our 3rd standard deviation, we can go 79, take away 8. We know we're going to be at 71. And to go this way, because our standard deviation is still 8, we're just going to plus 8. So we've got 95 plus 8, and now we're going to plus another 8. So 111 plus 8 is 119. So this is our graph. We have all our data that we need, and now we can use it to answer some questions. So the first question on your sheet says, find the percentage of footballers with chest measurements between 87 and 103 centimetres. So what we need to do is we need to find where 87 and 103 lie with on our graph. How many standard deviations? So first we're going to find 87, and we know that is 1 standard deviation below. Then we find 103, and that is 1 standard deviation above. And because the question says how many, or the percentage of footballers with chest measurements between these 2 figures, what percent lies within 1 standard deviation below the mean and 1 standard deviation above the mean? Look back in your notes. 68% of footballers have a chest size between between 87 centimetres and 103 centimetres. So that's the answer to our first question. And I'm going to stop there